Hello everyone, welcome back to the SimScope. Today we are building and analyzing a buck converter. In MATLAB or Simulink, I will show you how it works, how the waveform, and we will break down every part of the circuit in a clean and practical way. Let's get straight into it. Firstly, what is a buck converter? A buck converter is a DC-DC step-down converter. It steps down, it takes a high DC voltage and efficiently convert it into a lower DC voltage using high speed switching instead of power like a resistor based linear regulator. This circuit or this type of buck converter is a non-isolated converter, and it is also called as a chopper. So you will find this buck converter in your phone charger, laptop chargers, many power supplies, and lot of electronic devices are using this buck converter. For example, like to step down your 24 DC volt to 12 volt DC, or stepping down your 12 volt to 5 volt. So it is seen in many electronic devices. So how does the buck converter actually works? Before explaining that, I would like to explain what else are used in the buck converter. Firstly, you will see a DC voltage source. I'm using a battery of 100 volt and a switch. Usually it can be an IGBT or a MOSFET. And inductor, it is the key component here. I am using an inductor of 10 microhenry. Then it is connected in series to the load, simply taking a purely resistive load of 10 ohm. A capacitor is connected in parallel with the load for 100 microfarad, and you have a diode connected in parallel to the load. This acts as a freewheeling diode, and these are the values here. Now if you look at the bottom side, you will see that this slider is connected to the constant here. This constant, I am trying to define a variable PWM gate pulse, and this gate PWM pulse is generated using this circuit of PWM generator, where I am comparing my duty cycle. This is a duty cycle D with the sawtooth or carrier waveform given here at the bottom with this value, and it is generating a gate pulse of G, which is connected to the IGBT or MOSFET, and based on the pulse generated here, the switching will be controlled. Now the measurements that are required are Vs and input voltage source. Vd is the voltage across the diode. VL is the inductor voltage, and you have the VLoad or output voltage. Now, how a buck converter actually works. Here's a clean practical explanation of how a buck converter works. A buck converter uses two main states. One is a switched on and one when switched off. And as I said, the inductor is the key player here. Let's say I'm using a MOSFET here, and when the MOSFET switch is on, the MOSFET connects this input to the inductor, and the inductor sees the positive charge. So the voltage here will be Vin minus VL. Because the inductor resists sudden change in the current ramps up smoothly. And energy is being stored in the inductor in its magnetic field, and the diode is reverse biased. Therefore, nothing conducts in the diode. However, from source, inductor, then capacitor and load. So the current flows something like that. Now, when the MOSFET is switched off, this is switched off, the capacitor already have the stored energy, and an inductor also have the stored energy. So therefore, the capacitor will discharge its power to the load. Therefore, and the diode is reverse biased. So the inductor do not allow a current to drop instantly. It has been charging. This inductor has been charging. So the current cannot drop instantly. So it releases the stored energy through the load. And this forces the diode to turn on, giving the current path from diode to inductor. Now the voltage here, or the voltage across the inductor, will be negative V out, and the capacitor filters the triangular inductor current. It fills in the gap during off time and absorbs peak during on time, and the result is nearly a steady DC output voltage. Now V out is equals to dV in is the key equation that defines the buck converter, where your V out is the output voltage, and D is a duty cycle, and V in is the source voltage or input voltage. This is how this equation derives how the duty cycle inputs as a controlled output voltage. Now, if I already have 100 volt of input, if my duty cycle is 0.5, 100 times 0.5 will be around 50 volt. Therefore, when I simulate it, I am getting an output voltage of 49.59. And if my duty cycle is 0.1, let's see what my output voltage will be. So it is 0.9. Oh, it's 9 volts, sorry. From 100, it's 9. It's stepped down to 9. What happens if I make it to 0.8? Then it's 79.83. So you can see that when the duty cycle increases gradually, then the stepping down of your output voltage is also gradually step down. So if my duty cycle is less, then your buck converter can step down more, and if my duty cycle is more, then the buck converter or chopper uh, step down its capability to step down the voltage is less. Now let's see the waveform and analyze it. Firstly, I have input voltage waveform where I am giving 100 volt, and it is an input 100 stable, which is a straight line 100 volt. Then second waveform is a pulse, PWM pulse. The PWM signal shows a clean 50%. It's not 50%, so let me change to 0.5 so that you can see a 50% PWM pulse. Now you can see that your pulse is 50%. It's turned on for if 50%, turn off for 50%, and the voltage is stepped down. The output voltage is stepped down to 50 here, and the diode uh, then the diode voltage here, when the switch is on, then switching mode jumps to 100. So that means the diode is off, and when the switch is on, this node collapses to 0 volt, and here the diode is off. In case of our inductor voltage, you can see that inductor voltage is approximately 50 to minus 50. I would like to show you the inductor current here. This blue line is your inductor current, which is approximately 5 amps. Okay, that is the full breakdown of a buck converter. I explained you how it works and how it is modeled. And if you want this exact Simulink file, please check the link in the description, and you can get a link from my bio too. Hit like buttons, subscribe, and let me know what other converters or control methods you want to see next, like a closed loop buck. I can do buck boost converter. So just comment in the comment box for next video. Thank you for your time. Hope you learned something.